Hi guys, welcome to this podcast on stem and leaf plots, or more affectionately known as just simply stem plots. So many of you have seen them before, but you'll have to not only be able to create a stem plot on your own, but also how to learn how to analyze it. So as usual, we'll start with a diagnostic to see where how you stand on these particular displays of data. If you're all good with the diagnostic, then you're free to disregard the rest of this podcast and go on with the work in lesson 3 on the plan. But if there's any elements that you're unsure about, then I encourage you to listen to the remainder of this podcast. Okay, here's your diagnostic question. You've got a back-to-back stem plot representing Miss Ship's class and Mr. Chop's class. They sit the same exam, and obviously you've got some exam scores there represented as you can see it. So you've got 5 questions to answer. Have a go. If you're unsure about any of them, then perhaps you'd best listen to the podcast. There is one slide on analysing the shape of a stem and leaf plot, so maybe you just stay tuned for that. But if you're good with those questions, then there's really no need to listen to this podcast. So have a pause, have a crack at those questions if you're able to, and then we'll go over the answers. All right, guys, you've resumed your listening to the vodcast after pausing it, and we'll go over the answers. So Mr. Chop's class is represented to the right of the stem, and you can see from the values there, the lowest was 50. Miss Ship's class is to the left of the stem, and you can see that, well, you can determine that the median score will be 72. So we'll be going over that determination, that calculation in this vodcast. Which class had the most students? Well, if you count elements in the leaf, you'll find it's Mr. Chop's class. State the mode for Miss Ship's class. Now there's 2 values most frequently occurring. That's 68 and 74. Mode is the only one of the 3 measures of central tendency that can have more than one answer. And finally, the 5th question, which class had the better results? And it's appropriate to refer to the median, certainly the median rather than the mean, because Mr. Chop's class has a positive skew to it. Miss Ship's class is roughly symmetrical. So Miss Ship's class, you'd expect the mean and median to be approximately the same. But Mr. Chop's class, with its positive skew, it's a more accurate measure of centre if you use the median. Now, if what I've just said there in terms of shape is unsure to you, then perhaps you just listen to that one section of the vodcast. If you had general uncertainty with this task, then perhaps just listen to the whole thing. All right, so this is essentially a stem and leaf plot, the key characteristics of it. So what we're doing is taking a bunch of data and separating each data piece in terms of its 1 digit in the leaf and the rest goes in the stem. And then you need a key. So there's the key below. And that helps you identify what each element in the data set, how to interpret it. So 2/4 could be 2.4, or it could be 2,000 and 2,400, we don't really know, but that helps us identify it's just 24. So let's have a look. So this element here would represent, together with its stem, 16. Okay, let's choose another one. That element there, together with the 3 in the tens, 7 in the units makes 37, and so on. You can see here's the highest value, which would be 59, would be the largest, and the lowest would be 1/2 would be 12. Okay, so that's how to read it. The key is vitally important. Do you lose a mark if you don't put a key in a stem plot? Absolutely you do. All right, let's keep going. All right, so there's some important tips we've got to follow for stem plots. Let me just get rid of my pen here. Okay, so it's important that you make your stem plot an ordered plot. So when you're from lowest to highest for each leaf, for each stem value, each leaf is ordered from lowest to highest. Now that's done so that we can easily identify what the median, the middle value is, by just counting up the numbers in the leaf, adding 1, dividing by 2, that tells the placement of the median, and then we can do that again to work out the first quartile and third quartile values. All right, now elements in the leaf should consist of just a single digit. So whatever type of numbers we're dealing with in our data set, that last digit appears in the leaf, and then you create your stem accordingly, and it should all be made clear to the reader what type of values with the key. All right. All right, now elements in the leaf should be uniformly spaced. So you've got your, hang on, let me just grab my pen again. So you've got your stem, you've got your leaf. So what you have to do is ensure that all elements line up nicely, because that helps us determine the kind of shape of our distribution, so that the shape of our data set, how it's distributed. Is it more heavily weighted towards the lower end to the upper end, or is it sort of evenly spread throughout, or mostly clustered around the middle? All right, we have special terms for these different sorts of shapes. Okay, and they are as follows. So you can see the one on the left is a very common one. It's a symmetric shape. And if you can imagine just drawing a little curve over the lot of those, it's roughly centrally clustered. So it reaches the most values occur in the middle, and it drops off sort of roughly evenly to the left and right. Things aren't generally perfect in the real world, but that's a roughly symmetric shape. Let's compare it with this positive skew that was in the Mr. Chops example. If we were to draw a little curve over the top, you can see it tails off in the positive direction. So it's skewed. You get more values at the lower end of the scale than the upper end of the scale. And so that's got a positive skew. I know it's sort of, the way to identify positive or from negative is the direction of the tail. So it's tailing in the positive direction of the number values there. So it's a positive skew. Now there, we don't know what sort of data we're dealing with over there, but let's just, it's clearly got a negative skew to it. Why negative skew? Again, if I was to just grab the lot, put a bit of a sock around it, you can see it's tailing off towards the lower end of the scale. So it's because of the direction of the tail is towards the lower end, it makes it a negative skew. So over here, yeah, it was tailing off towards the top end, positive skew, tailing off to the bottom end, making it a negative skew. Okay, so, excuse me. So you'll only get that sort of shape clearly if you evenly space elements in your leaf. Okay, hopefully you can see that. Good. Okay, let's move on. Okay, this is the sort of activity you'll have to do in the forthcoming exercise. You've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 2, 28. You've got 28 different values. You have to arrange them into a stem plot or a stem and leaf plot. And from there, calculate the median and the mode, and then describe its shape. Okay, so I would imagine quite a few of you are capable at doing this without too much intervention, so I'll let you have a go. But please take note, only single digits occur in the leaf. So in your key, have a think about how your key should be represented. So if I was to actually talk about that data value in a stem and leaf plot, I would make sure in my key 4/1 was representing 4.1. So represents 4.1. Let me just get rid of that. 4.1. So that something like that would need to be listed in your listing of your stem and leaf plot. So I'd like you to have a go now. Organize those 28 pieces of data in a stem plot and see if you can answer those questions. Find the median, find the mode, and then describe its shape. Okay, When you resume this vodcast, I'd imagine you've had a go and you're ready to look over the answers. All right, you're back. So I take it you've had a go at answering this question and you're just checking out your answers. Good. Okay, the first thing is to represent all these numbers between, well, firstly, we should think about the lowest value in our data set and the highest value in our data set. Understand that our leaf consists only of a single digit, and this necessitates our key to be defined as follows, where our stem will contain the units and the leaf will represent the tenths involved in all of these data sets. Now our lowest value is 0.1, therefore we begin with a stem of 0, our highest value is 7.5, so we end with a stem value of 7. Okay, all other members of our data set can therefore be represented accordingly. All right, now take note, it's an ordered stem plot, and that's particularly useful in determining the median. We couldn't really determine the median directly from a stem plot without it being ordered. Okay, because it is ordered, we're ready to go. We know that there's 28 members of this data set, so the position of the median will be n plus 1 divided by 2. In this case, 28 plus 1 divided by 2. It'll be in a position that's between the 14th and the 15th element as they are ordered. All right, so let's go through and count them from below. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Aha, we found the location of the median. Okay, and just to confirm, just because we might have miscounted, it should be 14 from the maximum value counting downwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, I can proceed with confidence that I've found the location of the median. Now, what is the value of the median itself? Now, here's the tricky part. We're not dealing with 33 and 34. We're dealing with 3.3 and 3.4 as our key has indicated. So it's 3.3 plus 3.4 divided by 2, which is 3.35. Okay, that's the value of our median. Okay, we didn't really need to perform a calculation of that nature. Everyone knows what lies midway between 3.3 and 3.4, but there it is. There's the formula for calculating the average between two values. What about the mode? I hear you cry. The mode. Okay, what is mode? Most frequently occurring. So I'm scanning through the leaf for just visually catching the most frequently occurring digit on a singular row, and you can see clearly there it is there. So the mode, therefore, what are each of those values representing? Not 41, but 4.1. Okay, let's move all of this so we can think about the shape. If I were to trace a line around the outer boundary of each of those values, you can see, maybe I'll redo that. Let's just try to, there we go. Let's try all of that again. So, sorry. Okay, so what you should see is a distribution that the largest number of values occur roughly around the center of the distribution and sort of tails off to the left and to the right in roughly a similar manner. So I can draw the conclusion that this is symmetric in shape. Okay, so it's not always perfect, and that's how real life data is. Okay, hopefully that helps you. Okay, and this is just more of the same. Let me just get rid of that. Okay, just to recap, lies between the 14th and 15th values, 3.35, mode, data approximately symmetric. Okay, now back-to-back stem plots are really cool when you want to compare two different pieces of data sets. And I think we began with two different class results. So that's something you'd be interested in comparing, wouldn't you? Okay, so here we are. We've got scores for the last 30 football games. So in total, each of those scores represents one of the 30. So just count. Let's just have a look at this. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So they would have had a 12, 18 win-loss record. So there must be 12 winning results and 18 losing results. Okay, so and you can see the key that represents a loss of that's a heavy loss, a loss of 109. Their highest losing score was 111. Okay, these aren't losing margins; they're just losing scores. Our highest winning score was interesting. Okay, now let's just have a think about how to interpret back-to-back stem and leaf plots. So when it's a singular one, we have our stem and we move to the right with our leaf. Now, for an ordered back-to-back stem and leaf plot, this is the counterintuitive thing. We start with our smallest values closest to the stem, and for increasing values we move to the right. So because we're so used to reading things left to right, we order them in reverse to what we're used to, so from right to left. So you can see here that represents a winning score of 95, and there is a winning score of 97, so it's been nicely ordered for us. Here's a winning score of 101, there's a winning score of 108. So it's ordered when you're moving from a stem to a leaf on the left-hand side, you're ordering them from right to left as opposed from left to right, which is the more natural way to read things. Okay, what else have we got here? So that's back-to-back stem plot. You can see our losing scores. Let's just get rid of all of that. Our losing scores have a bit of a skew to it. So let's just put a bit of a line around it so you can see it's tailing off in the positive direction, so it has a positive skew to it, whereas our winning scores are roughly symmetrical in shape. Okay, we can calculate it's the median losing score, the median winning score, etc., and analyze in greater detail the fate of this football club. Okay, good. Hopefully that helps. All right, no better way in testing your newfound understanding of back-to-back stem and leaf plots is by taking a question and having a crack at it. So there you are, you're comparing the sales. So what is this data representing? Daily sales in a shop over a 16-day period. That's nice. We don't have to count the number of items in our data set, but what we want to do is compare different daily sales of shop A and shop B, and once we visualize it on a back-to-back stem and leaf plot, we can draw conclusions about how each shop is going. Now, it's again still important that you order your elements in each leaf, be it to the right of the stem or to the left of the stem, one value directly under the other, so you have nice even columns, and that'll facilitate a easy read of the shape of each distribution. So have a go at this. Have a go at this particular question, and then we'll come back and we'll go over the answers. Okay, you've returned, and there is the stem plot as broken into intervals of 10. It's a bit cluttered, as you can see. It's not particularly interesting. The lowest value is number of sales being single digit. The highest value is a number of sales into the 20s. It appears that shop A is doing significantly better than shop B. Hard to read exactly what any shape of distribution is. Now, if I asked you to redraw that with intervals of 5, okay, by increasing it from intervals of 10 to intervals of 5, have a think about how that would affect the general look of the stem plot. So if you want to pause it and have a go, I'm going to quickly run through that and convert that table to intervals of 5. and this is how it would be done. Okay, so I've got two lots of 0, two lots of 0 under my stem. That's the first 0 represents values 0 to 4, and the second is 5 to 9. Two lots of 1, 10 to 14, and 15 to 19. Two lots of 2. Okay, so what I'm going to do is put our line across, try to draw it neatly as I can. My handwriting is dreadful, isn't it? I know. Okay, there we go. There's our stem plot with intervals of 5. So what I can do is just take those values. So 0 to 4 would be here. Okay, and they've got a sale of 3 in shop A. So I should have labeled it shop A, and of course I'll keep the same key. 1, 3 could mean, well, actually interesting. How would you label a key with intervals of 5? Oh well, actually, because 1, 3 would obviously mark 13, and yeah, obviously, yeah, we don't need to. It won't affect the key because 3 by default would mean it's in the lower end of the 1 stem range as opposed to the upper end of the 1 stem range. Now the rest of these results, 6. So sorry, let's just be a bit neater, Mr. Jelinek. So let's 6, and let's try to make them evenly spaced. 6, 7, 7, 8, 9, 9. Okay, now there's no values to put in the shop A. Okay, so shop B, I'll just continue with shop B. It's a bit easier. So obviously that's 10, 12, 13, 14, 14. But 16 and 17 will be like that, and then there's nothing in the lower 20s, and you've got your 27 is the highest value. Let's just compare it with shop A. So you've got your 12, 12, 12, 13, 14, 14. Now 15 jumps into the next interval of 5, 5, 5, and that's it. And then we move into the 20s. So interesting, yes. So clearly doing much better. So this over here represents 21. That's not 12, but 21 because the stem is 2. So there's your 21, 22, and then there's 3 lots of 24. So I'm trying to line it up with the values above, so you get a sense of the distribution. And then this, of course, is 6, 7, and 8. All right, and I'll just change that color just to be consistent to the purple that I was using. All right, so guys, that's a little bit more spread out, and that's probably a bit easier to read, breaking it down into intervals of 5. You can see, you know, this is shop B's got a slightly positive skew to it. Not slightly, it's got a definite positive skew to it. And shop A, well, I don't know, maybe roughly symmetric. It's not really tailing one way or the other, but certainly the mean is certainly a much sorry, the median is further up the scale than that of shop B. All right, good. Let's see what else the question had to pose. Let's just keep this rolling. So shop A has the highest daily sales, clearly. Over here, there it is, 28. And its sales are generally between 12 and 28. Yep, certainly. It had a very low sale one day, which seems reasonable. Shop B between 4 and 17, and had a particular, so these would be almost outliers in the, well, that's certainly an outlier, and we could use our upper fence to test whether it is indeed an outlier. See if you want to go off and do it yourself. And this is potentially an outlier at the lower end, so lower than the lower fence as well. But that's all we have today. enjoy your frolic through statistics. We've released a heap of material out there on your OneNote for exam revision. If you want to start doing some exam revision, that would be highly recommended. So hopefully that was useful, and we'll see you soon.